Hello all. Today we're going to be talking about distance and displacement in physics. And we need to start with some terms and make ourselves familiar with them before we actually look at these two terms. So let's start with, in this case, the term scalar and the term vector. So we've got some terms we have to learn, and these are two of the new ones that we're going to be working with. A scalar is a measurement that gives us a magnitude only. So a scalar would be things like time, for example, 5 seconds, 2 hours, tells you a how much. The word magnitude means how much. You could also have speed, would be a scalar, 25 miles per hour, 10 meters per second. Those would be some examples of speeds. They tell you a how much. You could also think about this as distance. Scalar is distance. So you could say 100 meters, like in the 100-meter dash. Or you could have a 50 yards, like on the football field. Another scalar could be height. Person is 5 feet 6 inches. That's a height. So you could also say 66 inches. A person's weight would be a scalar. 200 pounds, 125 pounds. All those would be scalars because they tell us magnitude only. Okay? Just an amount. A scalar is any measurement that only tells me amount. On the other hand, a vector, which is a new quantity that we're going to use in physics, and we're going to be using it almost every day all year, is a quantity or a measurement that involves or that gives information about magnitude and direction. So we got to have magnitude and direction. So once again, magnitude is the how much. Remember, this is a how much. And direction is a which way. In the which way will be given, we will list directions as angle measures. And I'll talk about that when we get to it. I'll give you some examples here in just a minute. So, if we were to have an object that had let's give you an example of a vector quantity, we could say the velocity is 30 meters per second due north. That would be at 90 degrees as an angle measure. Because when you're doing angles, just to refresh your memory, this is 0 degrees, this is 90 degrees, 180 degrees, and 270 degrees. So due north would mean an object that is moving straight north. We could also have a velocity, something like this. Velocity is 10 miles per hour at 315 degrees. So 315 degrees would be 90, 180, so I'd have to move 180, then I'd come 270, and 315 take away 270, I would have 45 angle degrees left. So I'd come over here to the 45 degree line, and I would be going 10 miles per hour, and my angle measure would be 315 degrees. Now, there are some other ways to list that angle measure, and we will get into those later, but for today, it's just enough that you recognize that scalars tell you a number value only, an amount only, where vectors tell you both an amount and a direction. So velocity is a vector, displacement will be a vector, so we could say 10 miles northeast if we were doing cardinal directions, or you could say something like 5 kilometers at 20 degrees. Those would be displacements. And then acceleration will also be a vector quantity. So things like negative 9.8 meters per second squared, that's the acceleration due to gravity. Or you could have positive 3 meters per second squared, and that would tell us, and we need to give a direction here, so at, let's say, at 75 degrees. So there's some examples of each one. And the key words we're going to look at, the vocabulary words we're going to have out of here, are these. Height is not going to be one because height is a distance. So a lot of times in physics we just call it distance. We don't call it height or length. You just call it the distance. So now that we've got those two, let's talk about a few things from your guided notes. So one of the things in your guided notes is, what is one-dimensional motion? And so one-dimensional motion is motion along a linear path. It's motion along a line. So you can go in two directions. Two different directions are possible. So let me give you an example here. Let's say that here is our axis, our line of motion, and if we have a car going this way, the car could move to the right, so this would be a positive, we would consider this to be a positive velocity, because you are moving to the right. But you could also have a person that happens to be walking to the left, and that would also be one-dimensional motion. This person is moving along a line, so the person is moving to the left. So this person has a velocity, so the velocity will be negative. That's how we indicate it in physics. The positive sign and the negative sign gives you the direction amount, not like negative 5 is smaller than 5. Negative 5 is moving 5 to the left, where positive 5 would be moving 5 to the right. So we use positive signs when moving up or right. We use negative signs when moving left or down. And so that helps us tell which way the object is moving in this one-dimensional motion. Okay? So the other thing we have to keep in mind is that two people could see the same event and see them differently. For example, a frame of reference is what you consider, it's a point of view in physics. And different people will have differing points of view. So when you're riding in your car, if you look over at your backpack, let's say that this afternoon you have to get off the interstate, get onto the interstate and you're going to go down to Smyrna to see a friend. So you get in your car, you get on the on-ramp, you're going down the interstate at 75 miles an hour. You do not look down and go, oh my gosh, my backpack's moving 75 miles an hour. Or, oh my goodness, look how fast I'm moving in the car. Because to you, in your point of reference or your frame of reference, everything in the car seems to be stationary, and you seem to be stationary except for moving the steering wheel or hitting a gas or a brake pedal. The backpack appears to be sitting completely still. You can't tell you're moving until you look outside the car and you see objects on the sides appear to go, excuse me, pardon me about that. The objects on the sides, like the side of the road, it looks like the trees and stuff are moving backwards to you. Or a car that's coming towards you looks like it's coming really fast towards you, but a car that passes you looks like it's barely passing you. You only see a difference in speeds. So your frame of reference is going to be very important, and it's okay to have different frames of reference. Meaning that two people in physics could actually see the same exact thing, but describe it differently. So your frame of reference will be, the stationary background that you choose. So frame of reference is your stationary background. If you think about it for a few minutes, you'll probably realize that the Earth is the most common background. Although sometimes we look in space. If we look in space, we can tell we're spinning because the moon goes away. Pardon me, I'm really not this sleepy, but the moon goes away and the sun goes away. We might think that the sun orbits us by watching that. Our frame of reference, we appear to be stationary on the Earth, even though we are moving around the sun at like 20,000 miles an hour. But we're also spinning on our axis like 28,000 miles per hour, but we don't notice the spin of the Earth. When I look around on the Earth, I don't know that the Earth is spinning on its axis. My frame of reference appears to be stationary. So keep in mind that your frame of references depend on the problem you're working, and one makes it easy to analyze the motion. So you're looking for ways to make the problem as easy to grasp and work with. And like I said, the Earth tends to be the most common background. Okay, so frame of reference in one-dimensional motion. So we'll get into those some more, and we'll give you some more as we practice. But let's get our next two words and get those defined, and then we'll move on. So distance is the total amount of position changes done. For the total amount of position changes added together. If you want to think of it like this, you're going to count every step. Displacement, on the other hand, and I'm going to flip over to a new page. I know you can't see that, but you'll see that there's two pages. Displacement is the difference between starting position, or between final position and initial position. So displacement can be thought of like this. It's your change in X or change in Y if you're moving vertically. So for example, we'll give you some pictures. Let's say that we have marked out a football field. But our football field, we're going to start on one goal line, and here's 10 yards, 20 yards, 30 yards, 40 yards, 50 yards. And I ask you, let's say that a person starts here and ends here. So we start at 10 and we end at 40. If we were to do the distance would be 30 yards. The displacement, though, requires two pieces of information because it's a vector. So displacement will be 30 yards to the right. That's a time when distance and displacement have the same number value, but the displacement just adds a piece of information. In this case, the information is which way did you move. In another circumstance, or another example, let's say we have a person and their pet dog walking from their house to their friend's house so the two puppies can play together. So the path between the houses, here's house 1, and over here is going to be house 2. So there's houses. And we're going to walk with our puppy, which I am not even going to pretend that I can draw a puppy because we all know I can't. You don't know that yet, but I'll just tell you, I can't draw puppies. I can draw stick people. So here's my stick people. And my stick people are going to be walking to the neighbor's house. Well, as my stick person walks to the neighbor's house, what is my dog doing? Even if my dog is on a leash, but especially if he's not. If the dog is not on a leash and yet is well trained, he won't go very far from you, or she won't go very far from you. But the dog is going to do, ooh, let's smell the bush over here. Oh, let's come back and check with our owner. Okay, let's look at our owner. Now let's go over here and smell this tree. And then we're going to come over here and we're going to see what's interesting, and we're going to sniff everything. And the dog's path is going to be very all over the place, if you will. And even if they're on a leash, let's be honest, the dog gets excited and runs around you and gets tangled in your feet. And so dogs like to wander around and smell all the interesting things. That's the fun thing for them to do. And so when we get to the distance that the dog and I travel is simply how far it is for me. It's how many steps do I take. So the distance for me is the distance between the two houses, but the distance for the dog will be much greater than my distance. The dog's path, distance of the dog's path is much greater than the person's path. However, the displacement of the dog is going to be exactly the same as the displacement of the person. They both started at house number 1 and they both ended at house number 2. So the fact that the dog went every which way is completely irrelevant to the overall question of what's happening in terms of distance. And so when we talk about distance and displacement, the displacement of the person and the dog might be the same, but their distances be very different. So there's an example of where distance and displacement are very different. Let's do another one. Let's say that you're on the track and you've got track practice this afternoon. And you know, the track is kind of an oval rather than a circle. But if we're going to have track practice today, let's see what we can have happen. Well, if we start here, let's say we're going to start our training laps at this position. So we're going to call this our starting position. And if I run over here, my distance would be this whole part of the track that I walk on. So the distance is the path along the track. But if I do displacement, displacement is going to simply be the straight line distance, the shortest path, if you will. Displacement will be our shortest path between the 2 points. Okay? So, there's distance and there's displacement. And now let's tag on to those speed. Speed is total distance over total time. And velocity is displacement over total time. So let me give you another example from the track. Let's say we're going to run a 400-meter dash. Well, for most of you, that means if I start here on the track, I have to go all the way around the track and back to where I started. So the speed for the race around the track, whether I go this way or this way, the speed is going to be 400 meters divided by whatever time it takes me to do that. But the velocity will be 0. And the reason the velocity will be 0, and it won't have a direction because you don't have a direction because you didn't move. So why would the velocity be 0? Well, if I start at this location and I run all the way around the track back to where I started, then my displacement is 0. It's as if I did not move at all. And so my displacement is 0, even though my speed is a number. So keep in mind that velocity is going to compare with displacement. Vectors go with vectors and scalars go with scalars. Okay, so now you should be able to do the 2 worksheets that are at the bottom of the page. And if you have any more questions, please write them down in your notes, jot them down, email me, put it a post on the page for our team so that somebody else in the class can answer you, and we'll go from there. All right, have a great day, and I'll talk to you on the next lecture.